Two tiny conducting spheres are identical and carry charges of negative 21.4 microcoulombs and positive 50.3 microcoulombs. They are separated by a distance of 2.66 centimeters. What is the magnitude of the force that each sphere experiences? So let's draw a picture first to visualize this. So we have two objects. One has a charge of negative 21.4 microcoulombs and one has a charge of positive 50.3 microcoulombs. So first things first, let's just convert these to coulombs just so we have a uniform unit when we're using our formula. So we can just tag on a times 10 to the negative 6 and it will be coulombs. So negative 21.4 times 10 to the negative 6, and that is coulombs. So that's the charge of this particle, and then this one is 50.3 times 10 to the negative 6 in coulombs. So that is the charge of each of them. And then the distance is 2.66 centimeters. And we can change that to meters. So divide by 100 and we get 0.0266 meters. So now we have our values that we are going to plug into our formula, and I'm just going to circle them so we don't get confused. And so we're going to use Coulomb's law to solve for this problem. So it states that the magnitude of the force between any two point particles is equal to a constant K times the magnitude of the charge of the first particle, magnitude of the charge of the second particle, divided by the distance squared, so r squared. So we have the constant is equal to 8.99 times 10 to the 9th if we use coulombs and meters. And then we have, note that it's absolute value, so we won't put this negative sign in for the charge on particle 1. So 21.4 times 10 to the negative 6th times 50.3 times 10 to the negative 6th, all over the distance, which we converted to meters, 0.0266 squared. And that will equal to the force. So at this point, we can just plug all of this into the calculator, straight and simple, and we get the force, the magnitude of the force, to equal 13,676.6 newtons. And if you wanted to write that in scientific notation, you could do 1.37 times 10 to the 4th newtons. So this is the attractive force that the two particles feel.